Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about what actually you find inside a router. So that is what's inside a router. That means everyone maybe know the term a router. It is a device, of course, and what it is actually basically going to do in the network. So if you want to know that, so you have to see the lesson. You have to listen the lesson, so that after completion of the lesson, so I'm expecting that you will be able to know about the introduction to the router and what are the major components of a router and what are the functions of each and every component. I think you will be familiar. So let us start with the first one, that is called what actually a router means. A router is a networking device, and the major actual role of the router is to forward data packets, because once you combine all the routers in the network, so you can able to see the overall network from the sender to the receiver. So that is why in this complete scenario, so without forwarding, how you can able to transmit the data from the sender to the receiver? It's not at all possible. So forwarding is a very important factor to be carried out by the router. So router is going to take the information from the neighboring devices, and it actually find out whether the route is clear or not. So that is another important job of the router to identify, and based on the traffic, it is going to decide when to release the packet and when to hold the packet. So when it is releasing the packets to travel is referred here as a forwarding. So that is why the one of the important factors of the router is to collect the packets and forward them. And of course, it is also a kind of a traffic director. That is a name given to that. Why it is called as a traffic director? Because in the complete network, routers are placed at several locations, so you can establish the overall network by following several routers in this particular scenario, and all the routers may be combined to establish the overall network, of course. And in this case of the traveling of packets from source to the destination, so there is a big challenge that is there. So how or where or to which direction the packet is to be released? So that is another important role of a router, which is called as the traffic director, or which is going to decide which area is traffic free and which area is error free and which area is congestion free. So these are to be identified by the router, and that is why it is called as a traffic director. Okay, and also router is ensuring that data sent from a source reaches to the destination in a correct way. It should be reached to the correct destination. That is another important thing. That means based on the address, so the router has to decide to whom it is to be delivered. Suppose if it is delivered to a wrong device, so automatically the entire process is a waste process. So that is why router is also having a very big responsibility of handing over the information in the form of a packet to the proper destination. That is why these are the fundamental points related to the router. But basically, remember that router is a device. And now you can identify what are the actual, because it is a router is a device, what components you can identify in the router. Basically, there are four categories in this we are finding. One is called input port, that is number 1, and next is the switching fabric, that is number 2, and output port, that is another information, and there is one more thing that is called the fourth one, that is called routing processor. These are the four main components you can identify in the router. So because the components are different, so definitely you can expect the role of each and every component is also different. Now we have to look after what actually the role of each and every component in this complete the parts of the router. So let us start with the input port. Input port, suppose if you see again the figure, so in this the input port is going to receive the packets from the actual origination of the packets. So packets are originated from somewhere, and they are placed in the input port of the router. So the packets are not generated in the router. The packets are generated from the source and they are reaching to the input port of the router. So the input port is packets which are generated from some source. So that is why input port is going to say that receive incoming packets. Okay, and also implement packet queuing when network congestion occurs. Sometimes based on the capacity of the input port, beyond the capacity of the input port, suppose continuously the packets are coming to the input port. So the input port cannot accommodate all the packets. It has to hold and it has to prepare to put the packets in the form of a queue. So that is another important responsibility of the input port, and that is called queuing. And it has to avoid the packets to hold by the input port, because if over capacity, suppose if it is trying to hold the packets, there may be congestion that is possible. Congestion means overloading beyond the capacity of the actual device. If you are allowing, that can be called as a congestion. That means it is a overflow. So it is always a problem. So you cannot, you should not allow the packets to occupy more than its capacity. So that is why you have to consider this particular point, which is actually the responsibility of the input port. So what actually it is going to do? And of course, the second component, as far as the major components of the router, the switching fabric. So there are two important things we are wide identifying here: switching and fabric. Of course, switching is a concept by which you can say that a temporary connection can be established. Switching is always referring to provide a temporary connection between the devices. The devices may be directly source and destination, or the devices may be some other supporting devices. But switching is going to establish a temporary connection. By whom? By the router or by a switch, because these are the devices which can provide you a temporary connection. Then what about the fabric? Because it is a kind of temporary connection. By following certain permutations and combinations, the sender and receiver will be connected on a temporary basis. So that is why it is a kind of a fabrication you can call. It is not actually a fixed one. It is only a temporary connection. So that is why it is referred as a fabric. So this is carried out by three methods. That is why it is called as memory based switching, and bus based switching, and crossbar based switching. So these are the three types of switching fabric methods which are actually being carried out in the router. So depending on the requirement, it is going to follow any one of them. So now you see one by one. So let us say that the memory based switching. So see, or the input ports, let us say, and the memory is one of the important buffer you can call, where temporarily the packets which are actually been from the input port, temporarily they will be placed in the memory, and after that when the time comes, when the time says that it can release, then from the memory it takes the packets and it will be forward other side, that means to the output ports. So here XYZ are the output ports, and these are the input ports. So because why it is ABC and XYZ? Because you cannot restrict only with a single input port, and you cannot say only there is one output port. So there are several inputs and there are several output ports. So they should be joined with some kind of a on a temporary basis. There should be actually connected, or a connection should be established on a temporary basis. So that is why there are multiple input ports and multiple output ports are shown in this figure. And what actually the memory based switching is mainly focusing. So here the overall establishment of the temporary connection is purely based on the CPU control. So CPU will play a very important role for providing the temporary connection from the input port to the output port through the actual the router. So that is why the CPU control is responsible to establish a temporary connection So based on some logic in this. And of course, there is one more point that is called packet reception. So this packet reception is a process where the input port is going to receive the packets from some source. Let us say input port is going to receive the packets from source. Let us say, and once it is ready to allow the packets to travel, then it will give an interrupt signal to the processor, which is actually attached into this in the actual components. You are identifying that there is a routing processor here. It is going to, the input port is going to give an interrupt signal to the routing processor, saying that it is going to allow the packet to transmit from its side to the other side. So that is why whenever the input packet is there, actually it is actually the input port is going to raise a small interrupt signal. Then the processor is going to take the packet from the input port, and temporarily it is going to place the input packet into the memory of the processor. In the processor, the memory will be very, very small, but that memory is enough to hold the packet on a temporary basis time interval. So the packet will be taken up from the input port and will be placed temporarily on the processor memory for a small time interval. And once the actual the time comes that the route is free, which is actually been identified by the router, then it is going to release the packet. That is, the packet can transfer from the memory of the routing processor to the output port. So that is another important thing, that is called packet transfer. Packet transfer means because the packet is there in the memory of the routing processor, once time comes, once the route is free, then it is going, the router is from the memory, and it is going to allow the packet to the other side. That means it is going to forward the packet. So that is why the packet transfer is another important feature in the memory based switching. And routing decision. Even though we are finding it is very simple to see the figure and identifying the activities, but practically speaking, it is very difficult to decide about the best path by the router. Already I told you that router is a very important device which is going to decide the best path, but it is not very easy because it has to follow certain protocols or certain algorithms. So based on that, it has to decide which is the best path finally to be allowed by the packet to travel in the network. So that is why another important thing is called routing will be the best path will be decided by the router, and that is called as routing decision. And lookup and forwarding. So router is also having one more important kind of thing, that is called lookup. In the sense, it is a process, it is an activity by which the router is going to see whether the traffic on either of the sides of the router is free or not. That means any kind of traffic disturbance is there. Once it is going to release or before releasing the packet, it is going to check whether any traffic problems are there or not. It is, first of all, it has to check, and then afterwards it is going to forward the packet. So checking of the existence and checking of the clearance of the path is called as the lookup. And once it is identifying that the traffic is no, and the path is clear and the channel is free, then it is going to forward the packet by releasing the packet from its memory to travel into the actual the other side of the output. So that is why the actual lookup and forwarding is another important process in which you are going to see that the router is going to check the actual the clearance of the path, and after that it is going to release the packet to travel to the other side. So that is called forwarding. So this is the basic idea about how memory based switching is possible. So now another important thing is bus based switching. Here bus in the sense a common channel, a common wire, so a common cable you can call. So here also there are certain things which are actually be been to be which are to be identified in this. So here also, of course, ABC, XYZ are identified. ABC related to the input ports and XYZ are related to the output ports. But there is a common channel that is identified here in the red color. Suppose A is interested to talk to Y. So in the red, a common channel is there that is called a bus. So by using the bus, so A can able to temporarily have a transmission from A to Y. The same red color channel is also be possible to be utilized by B to talk to X. So similarly, B can talk to Z, C can talk to Y, C can talk to X. So like that, the same common channel can be used by different input ports to deliver the information or to transmit the information to the several output ports, but by using a common bus. So that is why this is called as bus based switching. Why it is called as switching? Because no input port is directly connected to no output port on a fixed basis. That is why it is a switching. On what basis it is possible? By using a common bus. So that is why totally it is called as bus based kind of a switching. So what are the basic functions in this? So in this, direct datagram transfer is possible. So here you need not involve any CPU control or any routing processor involvement is not necessary here. So directly the bus is able to deliver. It can able to take the packets from the input ports and it can able to decide to whom it is to be delivered based on the address header. So based on that, it is going to put the packet in the bus, and the destination stations can able to check the address to whom it is to be actually addressed. So based on that, they are able to take the packets into their area, so that they can able to get the information finally. So here the direct datagram transfer is possible without involving the CPU, as we have seen in the previous one, and also no routing processor involvement is seen here. And also single packet transfer. Any moment if you see that A can put only one packet at any moment, and once it is reached to the destination, then only A can put one more packet. Like that, one by one only it is to be taken into consideration. Suppose if accidentally more than one packet is actually been placed in this, then blocking will be possible. So to avoid blocking of that, so generally this bus based switching also encourages some kind of a queuing. That means putting the packets in an order to form a queue, so that one by one it can be released without any kind of blocking or congestion that is going to occur. So that is why this bus based switching is another important switching technique you can identify in this case of a routing. And this is also one of the important functions of the router. We are seeing that in this. And there is one more thing that I am going to say, that in the switching, crossbar switching. So in this means, so here if you see that the horizontal lines from ABC, that means the horizontal lines means these are the horizontal lines you can call. These are related to the input ports. The horizontal lines are actually are the lines which are reflecting the input ports and their actually data in the form of packets, whereas the vertical lines are actually identified here as the output ports. Whenever they are intersecting, so that is called as a intersection point, and it is called as a switch. That switch is called as a crossbar switch. So because there are 3 devices as input and 3 devices as outputs, so 3 cross 3, so you are able to identify 9 cross points, so 9 cross sections. So because there are 9 cross sections, so there are 9 switches you have to establish in the network, so that you can able to say that this particular kind of a connectivity is called as crossbar switching. So that is why this is identified as a crossbar. So in this case of the crossbar switching, of inputs multiplied by the number of output ports will tell you how many cross points are there. At every cross point you have to put one switch, so that the crossbar can be identified. So based on that, there are certain functions you can identify because of multiple buses and multiple switches, so you can able to get more advantage of by establishing this kind of a connectivity. So here by using this you can able to overcome the bandwidth limitation. In the previous two procedures there is a bandwidth limitation because the bus is having certain capacity. Beyond the capacity of the bus you cannot put any data in that. That is why it is a bandwidth limitation you can call. But whereas in this because there are 9 cross points, so the packet can travel by taking any bus and it can go in any direction, so which is suggested by the actual router. So there is no limitation of the bandwidth as far as this particular kind of switching is concerned. And there is one more thing that is called crossbar switch mechanism identified here. So what I mentioned is crossbar is actually a multiple, a multiprocessor kind of an environment you are able to identify, multiprocessor environment. Suppose you have a single processor, so because of its limitations it can carry out certain processes, but if there are multiple processors, so you can do multiple activities. Similarly, in this crossbar switching, so there are multiple cross points are there, multiple switches are there, so that you can able to use any switch for completing your operation. So that is why crossbar switch mechanism is more and more powerful when compared to the earlier methods. And of course, here packet routing through buses. So here also the routing is actually be possible, but the packet will travel by using any bus that is vacant, which is suggested by the router in the overall scenario. So packet routing through buses. So router is going to direct the packet to the best path, and also it has to travel through the bus. So that is why this is called as a packet routing through buses is possible in this. Blocking and queuing is another important thing because here the input ports are releasing a number of packets here. The packets can travel by taking any direction, by taking any switch or by taking any router, by taking any bus, so they can travel to the other side. But if it is beyond the limit, again there is a possibility of blocking. And to avoid that kind of a problem, so queuing is another technology or phenomena that is followed in this particular crossbar switching. But overall, when compared to the previous methods, this crossbar is more powerful. But to establish this crossbar switching, it is very expensive. So that is why. So you see the actual the components of the router is going to suggest you the various phenomena, various techniques, so that depending on the requirement you can able to take one of them. So that is why we are going to see the other port that is called output port. So the output port is called as the final destination port. You can see is where the final receiver is ready to take the information. So what actually the job of the output port? It has to transmit the packets to their appropriate outgoing link, because that side the receiver is available to take the data. So that is why transmission should be possible to the end of the actual processor. So that is why transmit packets to their appropriate outgoing link. Suppose if it is not placed in a proper link, so it will be taken up by the receiver, which is not a proper receiver. Then the transaction is completely a waste transaction. It is waste of time, very expensive. So it is not actually been advisable. So that is why what we are actually identifying here is transmission should be done only to the appropriate receiver. That is possible only by placing the packet in the appropriate link. So all these things are interlinked. And also the output port is going to handle queuing and scheduling to manage traffic efficiently. So because queuing is a very important phenomena to be followed by the devices at every instant, because if they not follow the queuing concept, then definitely it leads to congestion. If congestion takes place, it will be more and more burden to the router to fix up the best path, so that the router always control this kind of an accident of the congestion. So by following a phenomena called as queuing. And also scheduling. That means scheduling is nothing but when to release the packet, up to what interval the packet is to be holded. So that is another important management, we call it as scheduling. So that is why by following this queuing and scheduling, you can able to manage the traffic overall. So that is why, so this particular handling, queuing and scheduling is another important feature which is identified in the output port, basically to manage the traffic. And there is one point that is called buffer packets if outgoing links are congested. Okay, buffering is another important area where temporarily the packets will be holded. Buffer is nothing but a small memory area. You have seen that a processor, routing processor is having some small portion of memory. That means when compared to the memory of the whole system, this buffer will have a small amount of memory. So where the packet will be holded routing processor on a temporary basis. So that is why the memory is kept very small, and there the packet will reside only for a certain small time interval, and once the way is clear, it is going to put in the outgoing link, so that congestion can be controlled with this kind of simple technique that is followed in this overall transmission. So buffer packets if outgoing links are congested. Whenever you are already noticing that the congestion is already there, then still if you allow the packets to travel or occupy the link, then automatically the problem will be more and more serious. So that is why the buffer is another important technique that is used, where on a temporary basis the packets will be placed in the buffer. So whenever the way is clear, the buffer is going to release the packets, and based on that, or the packets will be taken up from the buffer and will be put in the outgoing link, so that the appropriate receiver can able to get the information in a proper manner. So that is about the actual the major components of the router, and what actually the portions that are there in the router. So that's all for today. I hope that after completion of this, so I hope you are able to know what actually the router can do, and what are the major components of a router, and every portion of the router. Simply speaking, there are 4 important things we have identified: input ports, and then there is an output port, that is a switching fabric is there, and the routing processor is there. So there are 4 important components we have identified. We know what actually the each and every component's role in this overall router and its mechanism, and functions of each and every component also. I hope you are clear.